Alright, so here is a video with the rest of the breakdown for this periodic table, and we'll work a couple practice problems with these quantum numbers. So we've done the S, the P, and the D blocks, and now I want to do the F block. So here's the F block. The F block, remember, it's lanthanides and actinides, and in this you're going to follow the same suit that you've always been following. So the question is, if you're in the F block, then what is L? If you're in the F block, you should know L has to be 3. So then what's M sub L? M sub L is the range. It goes from negative L to positive L. So it's going to go from negative 3 to positive 3. So in this case, we got negative 3, negative 2, negative 1, 0, 1, 2, 3. So you now have the breakdown of each one of these columns. So here's the columns. So we'll start negative 3, negative 2, negative 1, 0, 1, 2, 3. And just like before, what do you do whenever you went through the first pattern? You now go back and repeat. So we have negative 3, negative 2, negative 1, 0, 1, 2, and 3. So now in this, we have broke down the column. Now, just like before, the pattern for the spin quantum number, the first set of the pattern is plus 1/2. So this is a plus 1/2, while the second set of the numbers is the negative 1/2. Now the big thing to remember here is whenever you come down here, this is not the 8th and 9th row. Remember, these two really fit in this spot up here. So these rows are really setting right here, but it would just make our periodic table look really weird if we did that. So what we'll do is leave these lanthanide and actinides down here in a separate region in the F block, but you got to understand that they go up there. So you have to understand that the lanthanides here, this is the 6th row. And the actinides, this is the 7th row. And in that case, you also have to remember, for the F block, that N, the principal quantum number, is equal to the row minus 2. So let's find us an element and let's get the 4 quantum numbers for it. That didn't work out how I wanted it to. So we'll do the 4 quantum numbers here. So N, L, M sub L, and M sub S. My S looks awful, but that's an S. Alright, so in this, let's choose our element. I'm going to choose uranium. Atomic number 92. So in this case, I'm going to start, I told you guys how I like to start as always with L. I'm in the F block, so that means L has to be 3. Mr. Hall, how do you know that? Because I'm in the F block. Remember, S block is 0, P block is 1, D block is 2, F block is 3. So, now I move from L, that's narrowed me down to the F block, and I go to N, the principal quantum number. So I find where I'm at. I'm here at uranium. I'm in the 7th row. But I remember to find the principal quantum number for the F block that N equals row minus 2. So 7 minus 2 will give me 5. M sub L, that's the orientation. At that point, I find the orientation. If you break down your periodic table, you can just look directly above. It is 0. And then the spin quantum number, it's the first time I see the set of numbers, so it is plus 1/2. And that is how we break down the periodic table to get us to where we can have this set of quantum numbers ready for us to just really solve really quickly. That's what I like to do here. I like to make it to where you guys can break this periodic table down super quick. Take a little bit of time, break the periodic table down, because whenever you do that, then when you're solving for it, it makes it super fast for you. Okay? So let's go, oh man, I didn't want to say that. Let's go into big scale here. Alright, and let's practice a couple of these. So here's what we're going to do. Let's slide this over. Doesn't want to slide. So let's practice a couple. Alright, so in this case, we're just going to choose an element. So, for whatever reason, I'm going to choose gallium. So let's find the 4 quantum numbers for gallium. So in this case, gallium is in the P block. I know it's in the 13th column, that's in the P block, so that means L has to be what? You should be answering 1, because the P block is always 1 for L. So then from there, let's find N. Now remember, for P block, N equals rho. So in that case, 1, 2, 3, 4. I'm in the 4th row, so N is 4. Now I need to find M sub L. So on your periodic table, you probably still have it broke down to where this is -1, 0, 1, -1, 0, 1. So you can just look and see that that's -1. If you're looking and wondering where I got that number from, that's just breaking it down. What's M sub L? From negative L to positive L. If L is 1, that means M sub L can be -1, 0, or 1. That's the columns. -1, 0, 1. And then it repeats, -1, 0, 1. So now in this case, we need the spin quantum number, and it's in the first set of the numbers that I get, so it has to be plus 1/2. If you have questions on this, you need to write this down. Alright, so we have the spin quantum number. Those are my 4 sets of quantum numbers for gallium. Alright? So let's try another one. Alright, so in this, let's do nickel. Alright, so nickel is in the D block. So what does that mean L is? L is 2. Alright, what is N? 1, 2, 3, 4. I'm in the 4th row. Does that mean N equals 4? Hopefully you are telling me no, because you're in the D block, and for the D block, N is equal to rho minus 1. So we take the row, we're in the 4th row, subtract 1, 4 minus 1 is 3. Then we have M sub L, so we look, L is 2, that means we start with -2, 0, 1. Hold up. So we start with -2, -1, 0, 1, 2. Then we repeat -2, -1, 0, 1, 2. Alright, we're over a 0. So that means M sub L is 0. And spin quantum number is at the first set of the numbers of the pattern, or the second. That is the second. So that means we have -1/2. Okay? I will go on and preference here how you actually can use this information and you can go the other way. I can give you 4 quantum numbers, and you have to determine the element for me. Super, super, super important here. Alright, I'll do one just to give you an idea of it, and I'll go on and tell you this is where we're going to pick up whenever you come back in class after your quiz. So in this, say I give you the quantum numbers. Just for the fun of it. I'm figuring it out. So let's do no, let's not do that one. Let's do let's do 5, 3, 'Alright, so it goes like it has before for you whenever you're solving for these. What you're going to do is you're going to pick up and you're going to use this information and you're going to find your element. So in this case, make it simple for you. We're trying to narrow it down for us. So in this case, look at L. We're going to find the block we're in first. L is 3. What does that mean for us? L is 3, which tells me we're in the F block. So I now have it narrowed down here. Okay? Let's narrow it down some more. N is 5. Well, I know I'm in the F block. I'm trying to find the row now. Remember that for F block, N equals row minus 2. Now I'm trying to find the row. So in that case, I know that the row is equal to N plus 2. What's N? N is 5, so 5 plus 2 equals 7. I'm in the 7th row. Now I've narrowed it down to here. Now let's use M sub L. So my orientation is 3. So let's go on and label this out. -3, -2, -1, 0, 1, 2, and 3. Repeat. -3, -2, -1, 0, 1, 2, 3. I know I'm looking at 3. Since I'm looking at 3, let's look. Here's 3. So element 95, americum, and element number 102, nobelium. I have it narrowed down between those two. Now I got to decide which one it is, which is where the spin quantum number comes in. Plus 1/2 tells me that it is the first one of my elements and not the second one. So it is element number 95, americum. And that's how you do that. Don't worry about it. Whenever you come back in class, we'll hit this up and I'll break it down and go through some more. If you guys have any questions, you need to message me on Remind or reach out to me. Besides that, keep studying for that quiz. You will have that quiz. Even if we have a 3-hour delay, you're going to come into my class and you will be in my class for a full 45-minute class. So you will take the quiz. Besides that, if you have any questions, reach out to me. Help you as much as I can.